Hello everyone, welcome back to MAC1114. In this video, I will be introducing a new coordinate system we call the polar coordinate system. As we already know, the OXY coordinate system, we usually call it a Cartesian coordinate system because it's invented by René Descartes in France in about 18th, 17th century. And with the regular coordinate system, the OXY, we can display location of any object by using a point on the XY plane. Okay, and in this video, I'm going to show you how I'm going to display the location of a point using a point of the object. Location of objects using the point on the polar coordinate system, and what's the difference between polar coordinate system and the Cartesian coordinate system, which is the OXY plane we usually have in geometry or in trigonometry. So far we've been using that. Okay, so let's get started. Polar coordinate system. So I'm going to put the topic right over here. Polar coordinate system. Okay. Okay, so let's get started. By do some quick recall on the regular rectangular coordinate system, which is the XY coordinate system. Okay, so this is what we usually have, right, to display the location of the object. So I think I'm gonna use this color right here. Okay. Okay, so we have this is our rectangular coordinate system, right? This is our rectangular. Oops. I cannot draw the straight line. I try to be perfect. There you go. So we know this is Y, this is X, and let's say the location of an object is right over here, at a point right over here, and we know that a point has two components, right? We have let me call it as the point A has a component X and Y. Okay, and so the component X, it represents the distance from here to here. So this is your X, right? Okay, and the component Y represent the distance from here to here. Okay, now I just go ahead and connect point A to the origin. Okay, I connect them. Oh my God, I cannot draw the straight line today. Okay, so the point here. So try to. Here you go. Okay, I'll connect them, and I'm gonna call this the distance R. Okay, so you see that I have a right we have a right triangle here, and the distance R over here is the length right over here. The segment over here, it creates an angle with the positive x-axis, right? So this is, I'm going to call angle theta. Okay, now you see that the location of the object A over here, by using X and Y component, we can portray what it is in the coordinate system, right? Or we can use the R, which is the length of the segment OA, and the angle to portray the location, okay, to displays the location of point A. Okay, if we use r and theta, so this one I'm going to put over here. This one is the rectangular coordinate system. If I use angle theta and radius, I'm going to call this r over here. Then I can displace the location of point A on a different type of coordinate system we call a polar coordinate system. And the reason I call the radius over here, because if you imagine, if I go ahead and draw a circle with radius r, okay, with radius r, so we can portray location of any point on that circle using the r and the angle theta. If the angle theta could be positive or negative if you go clockwise or counterclockwise, right? So so after we already know how to derive the polar coordinate system by the rectangular coordinate system, so this is our new coordinate system, the polar one. This is what it look like. Because see that I have to draw many circles, so I cannot draw the circle over here. So I just get the picture so that you can see what it look like, what a polar coordinate system look like. Okay, so let's see. I can import a picture over here. Not. Let's see. I have let's see. I'm gonna import it. I probably suddenly forgot how you do that. Okay, I think it's over here. Image. Sorry, I tried to. I try to get the picture. I think right here. There you go. Okay, so this is what the polar, I'm gonna do it really big. So this is a polar coordinate system look like. So you see that right over here we have the x-axis, right? And the r could be small or big, depends on how small or big the circle is. So this is 90 degree, there's x and y over here. And O over here we don't call the origin, but we call it the pole, the polar axis. This is polar axis, and then point O right here we call it the pole. Okay, O is the pole. Okay, so I'm going to use a different color. I think I'm going to use this one right here. So O is the pole. Okay, and this axis and this axis we call the x and y over here, x and y axis, we call the polar axis. Okay, polar axis. And you see that it covers 360 degrees, right? All of them. Okay, and the angle could be negative. You go again. It could be, if you go clockwise, and positive you go counterclockwise. The R is totally different, right? The R is depends on how big the circle is. So this is R over here, R equal 1, then 2, 3, right? 2, 3, 4 right here, okay, and 5, 6, and so on. Okay, so this is the polar. This is polar coordinate system. Okay, I'm gonna write over here. So this is polar coordinate system. Look like. Okay. I think I'm gonna. Oh, okay. Now I'm gonna go ahead displace some location of our object by using the point on the polar coordinate system. So we know the component of a point on a rectangular coordinate system is x and y, but the component of a point on polar coordinate system will be r and theta. So a point over here, the component will be r and theta. Okay, r and theta. This is will be a x and y, and this is r and theta. So in order to displace the location of an object by using the point on polar coordinate system, you need to know r, okay, and theta. So you see that you can derive the polar coordinate system by using regular rectangular coordinate system. That's why we have a relationship between polar and rectangular coordinate system. I'm gonna give you some example, and I'm gonna give you the relation, and based on the relation, how we're gonna learn how to convert between polar to rectangular and from rectangular to polar. Okay. Now in the first example, I just want to plot some point on polar coordinate system. Okay, and the point I want you to plot is the following point. Point A for 45 degree, B -645 degree, C 7 to 40 degree, and D 30 minutes. Alright, sorry. Alright, I still have allergy in the morning, so very bad. So in order to locate this point right here in polar coordinate system, you need to look at the radius and angle, right? But the trick is this, okay? The trick is this. I'm going to show you. Okay, you always look at the angle first. Always, okay? Always look at the angle. Okay, so I'm gonna put in red color over here. This is the trick I show you. Okay, so always, okay, always locate. Always locate the angle first. Okay. Always. Okay. We mean always look at the angle first. So now you look at angle 45, which is angle theta right here. See that theta is 45. 45 where? 45 right here, right? 45 right here, and it's positive, so we had to go clockwise, so we had to go up, right? So it will be positive 45, and the radius, the radius is 4. So where's 4? I mean the 4 circles from the inside out. So this is the first one, right? This is the first one. I don't know, we count this one. I think we can count this one also. So this is the, or maybe, yeah, I think we're gonna, or maybe they start counting from here because they draw this, because they don't draw the circle here. So the first circle you draw, okay, the smallest one circle, this always r equal 1. So I think this is also another circle right here. So let me see, it's also another circle. So I'm gonna go ahead and draw the circle, small circle right here. So the radius over here is 1 right here. So this 1, 2, 3, 4, 5, and over here R is 4, so mean the 4th circle from the inside. So 1, 2, 3, 4. 1, 2, 3, 4, and 45 degrees. So it's right over here. Right over here is the location of point 8. Okay, it's location of point 8. So I'm gonna put you know what? I think I'm gonna use different color. So this is location of 1, 2, 3, 4. So this location of point A right over here. I don't know. The yellow is this one is not really good to see, right? I think let me use the 1, 2, 3, 1, 2, 3, 4. Pink is easy to see. There you go. So that is point A right over there. So that is point A right over there. So this is point A. Okay, point A. And now same thing. When we look at the 45, but the radius is -6, so 45 is still positive, right? So it's still positive. We still counterclockwise, but because the radius, the R, is negative, so you must go the other way around. So 45. So this 1, 1, 2, 3, 4. So this is point B right over here. Okay, so you see that you look at the angle first, then you flip to the other side, depends on the R. So if R positive, you still have the positive side, but if R is negative, oh I'm sorry, this is -6, not -4. So the 1, 2, 3, 4, 5, 6. So this is B right here is -6. 1, 2, 3, 4, 5, 6. Okay, which is the 6th circle from the inside out. Now you do similarly to 240 degrees. So return 240 degree positive. So 240 degree positive. So we're going to go this way. 240 degree, which is this one, right? And it's 7. It's 7. So it will be 7. So 1, 2, 1, 2, 3, 4, 5, 6, 7. So point C must be over here. Okay, that's point C. Okay. And now upon D is -75. So -75, which is we have to go clockwise, right? 75. -75 is about how many you go? Anyone do a quick? Do 90 minus 75. You what? It's 15, right? Let me see. I just want to be more accurate. 90 minus. So 15. So this is 30. 15 over here. So -75 must be this way. It's will be 285. It will be 285. The same as 285 if you go counterclockwise. So -75 will be this one. So we'll be in this axis right here. In this axis right here. So and the D equal 3, so it will be 1, 2, 3. So C must be over here, right? C. Oh, D, I'm sorry. D must be 1, 1, 2, 3. So D must be right over here. The 3rd circle from the inside out. Okay, the 3rd one. Alright. So this is very easy, right? There's nothing hard over there. Now, what if, in the second example, what if the angle they give you is in terms of radian? So how we do that? What if the angle is what if point A over here is 8 and power 6. Point B is 5. We do 3 power 4. Point C is -7. 2 power 3. And point D is -9. Power 6. Okay. Alright, so same thing. I mean, just imagine this is a 30 degrees, should be power 6, 30 degrees over here. So this 8 units, so it's going to be positive. So this, I'm going to use different color for this. So I'm going to use, what color should I use over here, guys? I'm going to use this one. Alright, Now I'm going to use the green one. I want to use the purple. How come we don't have the purple? You know what? I tried to get the purple. Oh, right over here, right? This is red. Now this is not good. This color is not good. I try to get the purple. Let's see. I can get the purple over here. Okay, there you go. Pink is not good, right? Pink is. How about red? I think go for red is even better. Pink is not good. So let me. Maybe this is not erase. So I'm gonna do this red, 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 red. There you go. Now I'm gonna do purple. Or maybe I'm gonna use this one right here. I'm gonna do this one. Pi over 6 is 30 degrees, right? So this I'm gonna call it A prime, okay? A prime, B prime, C prime, B prime. Okay, so this is right over here. This is B, this is C, this is D, and this is A. Okay. Now this one will be pi over 8. So we 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So A prime must be over here, huh? That's A prime. The color is not good, right? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 should be right over here. There you go. Purple not good either. Purple not good either. Maybe this one. 1, 2, 3, 4, 5, 6, 7, 8. There you go. I don't know. You can see that as so. This is it's hard to see, right? It's hard to see. Maybe I'm gonna go back to this one. Or maybe we use the. Oh yeah, why don't we use just black colors? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So right over here. There you go. This is A prime. There you go. Black is good, right? Okay. And find negative 3 pi over 4. So negative 3 pi over 4, pi minus pi over 4. So will be right over here. Right over here, because negative 3 pi over 4 is the same as negative pi minus plus pi over 4. So we right over here, the other way around, right? So we must be on this side right over here. So it will be how many degree? If you go ahead and calculate to the degree, it will be easier, right? So we 3 times 180 divided by 4. So we 135, negative 135, 360. So we 225. So which is right over here, okay? And it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So right over here. There you go. This is B prime. Okay. Alright. That's B prime. Okay. Okay, that's B prime. You know what? There you go. And it's negative 7. Okay, so this 2 pi over 3 clockwise. So this is counterclockwise. This is clockwise. So you go the other way, and this is 2 pi over 3. So pi minus pi over 3. So it must be on this side, right over here, right? This is pi over 3. So this is 2 pi over pi minus pi over 3. You go you go counterclockwise, and it's -7, but it's supposed to be over here if it's 7, but because it's -7, so you gotta go the other way around, the other side. So it'll be 1, 2, 3, 4, 5, 6, 7. So over here one C prime. Over here will be one. Oh, we see pi minus power 3. Power 3 is 60 degree. I'm sorry. So it will be, it is 30, 60. So we'll be here. I'm sorry. So it will be right over here. Right here. This axis, you see that? Right here. 1. You gotta go through this. 1, 2, 3, 4, 5, 6, 7. Right over here. Okay. Right over here. That could be upon C. 1, 2, 3, 4, 5, 6, 7. So this is one upon C prime right over here. Okay. And now negative power of 6 will be this one, right? Negative power of 6 will be power 3 here. Negative power of 6, which is this way, right? This way. Well, no, this way. It will be this way, and this negative power of 6 will be negative 30 degree. Negative 30 degree, right? And if it's positive 9, so it could be over here because it's negative 9. So you gotta do the other side. So we're gonna go this way. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So right over here. So it'll be upon D prime. So this is D prime. Okay. So the trick over here is very important. I mean, the trick over here is like, I mean, otherwise if you don't follow this trick, then it's very easy to get wrong, you know. You don't want it. So this is very important right here. Okay, so I'm gonna put a star right there. Okay. Alright, so that is how you locate a point using on a polar coordinate system. Now I'm gonna give you the relation between the rectangular and coordinate system, and how we're gonna convert. We learn how to convert between polar and the rectangular one. Okay, so we know that over here, if you look at the right triangle over here, we know this over here is hypotenuse, right? So the relation, the first relation, I'm gonna put over here polar, rectangular coordinate system relation. Okay. There you go. Alright, so we know that this is the hypotenuse, so we know that R. So we know that R. So I'm putting use different color. R is R square, right? Of course, is equal to x square plus y square. Okay, so R square. It's not good, right? It's not good. I mean, the color is not good. You know, I'm gonna keep using this one. R square equal to x square plus y square. Okay, and if you see that sine of theta over here will be y over r, right? Sine will be y over r. So from here we can find y. It will be r sine theta, and cosine theta will be x over r. Then from here we can find x will be r cosine theta. So this is the relation. So you see that you can go from the polar. If you know the angle, we can get the y and the x. Okay, and of course a tangent will be easy, right? Tangent, so tangent theta, right? So from these two, so if you go ahead and set up a ratio, tangent theta will be y over x, right? And it's if you look at it, the picture, of course, tangent will be opposite over adjacent, right? So this is the relationship between a polar coordinates and rectangular coordinates. Now I'm going to give you an example. Okay. Okay. Example number 3. Alright. So for this example, I'm gonna show you how to convert polar one. Let's convert rectangular to polar first. Okay. Convert point A rectangular form is 1 square root of 3. And point B square root 3 1 into polar form. Alright, so polar form will be what? The polar form is this is polar form, right? We need R and theta. So R is the distance. So R can be found easily. R will be square root of 1 square plus square root of 5 square will be square root of 6. Okay. And theta can be found very easy also, very easily with tangent. Tangent theta will be y square root of 3. So over here, theta could be because tangent will be positive, right? So it could be in the first quadrant and the second quadrant anyway. So so let's pick one of them. Okay, let's just pick one of them. So theta will be pi over 3. Okay, pi over 3. Okay, so let's pick one of them. Just pick one of them. That will be 5. Okay, because over here I just assume that actually the R over here could be positive or negative. So I assume that so R over here positive. Okay, and just assume that the angle theta over here is between negative pi and pi. So they have to define the R and theta for you, okay? Positive or negative in a certain restriction. Otherwise, you see, because tangent are positive, we have quadrant 1 and 2. So look like there are like 2 of them at least, right? But because it's we define that between negative pi and pi, so we're gonna just pick this one. So now the location, the polar form of point A will be square root of 6 pi over 3. Okay, and you do the same for B. Point B will be negative square 3, negative 1. So from here we can get R will be negative square plus or minus 1 square. Should be 2, right? Will be 2. And now tangent that will be opposite will be negative 1 over negative square 3. So we square root of 3 over 3. So it will be pi over 3, pi over 3. So theta is pi over 3. And we also put the restriction. Restriction is between negative pi and pi. Okay, we're gonna use the same restriction over here. So polar form of point B will be 2 pi over 3. Okay, so very easy, right? Yeah, I mean, you convert this like from rectangular to polar will be easy. How about if we go from polar to rectangle? Okay, it's polar. Okay. Into rectangular form. Okay. So rectangular form is x and y. We already know that this is rectangular form x, y. So we're going to use the relation. We know sine x will be r theta, r cosine, and y will be r sine. Actually, in pre-calculus, we know this. I think so. We already learned this. So here we can find x will be r cosine theta. So r is here, will be 5 cosine pi over 6. And cosine pi over 6 is pi over 6 is 30 degrees. So it will be square root of, no, will be 1 over 2. Will be 1 over 2. No, cosine pi over 6. 30 degrees square root 3 over 2, I'm sorry. So 5 square root 3 over 2. Okay. Square root 3 over 2. Okay, that's why the axis y is going to be r sine theta. So it will be 5 sine pi over 6 of sine of 30 degrees. So it will be 1 over 2. See? Done. Too easy, huh? Too easy, like 2 lines. So from here we can, now the point will be 5 square root 3 over 2 pi over 2. Oh my god, too easy, huh? And you do the same for point B. Too easy, very easy, guys. Cosine. So it will be negative 3 cosine of 3 pi. Of course, you need to know how to evaluate trick. So 3 pi over 4 will be pi minus 1. So it will be second quadrant. So I'm going to do it quick over here. So second quadrant will be negative, right? So it will be negative cosine pi over 4. Right, because second quadrant. Okay, so it will be cosine pi over 4 square root of 2 over 2, so negative square 3 square root of 2 over 2. Alright, and y will be r sine theta, and r will be negative 3 sine of 3 pi over 4. So this is negative, it will be sine of 3 minus 3 pi minus pi over 4. So sine pi, so this second quadrant positive, so it will be sine pi over 4. So negative square root of 2 over 2. Okay, so from here we can get point B will be 3 square root 2 over 2. And negative square root 2 over 2. Okay, see, super easy. Now in the next example, I'm going to give you an equation, and this equation is in rectangular form. Actually, again, I mean, if you learn, you had pre-calculus with me, this we already learned. So I'm going to just go ahead and show you one more time, especially for those who had not taken a pre-calculus. So example 5. So I'm going to convert this equation x y y square, this is rectangular form of the equation, into a polar form. Okay, to polar form. Okay, so we just use the relation between polar and rectangular. So x will be r cosine, r square will be x square plus y square. So x square plus y square. Okay, so over here x square plus y square is r square. And x could be r cosine theta, right? 0. Okay, so from here we can do a couple more steps. So we can write r will be r minus 2 cosine theta. Okay, and from here we can go ahead and split them up. So it will be r will equal 0, r minus 2 cosine theta equals 0. That's it. That's it. You don't have to solve anything. Okay, we just converted that to that form. The reason I keep going over here because if I keep going like this to get the r, it's easy for me to graph this on polar coordinate system. But the thing is this: in the next section, 7.2 is about graphing, but I won't be focused too much on the graph because we don't have graphing paper, right? We must have a polar graphing paper. So I just go ahead and I mean because we're gonna learn that again in calculus 1, calculus 2, I believe so. So it's not really important at this time. Go to graphing, you can use the TI for the graphing. It's not really important, believe me. Okay, so I'm gonna go ahead and skip the graphing part. Okay, just this is good enough. Okay. Okay, so from here over here I can get R is 2 cosine. Okay, this is the graphing. This is what you're gonna need. You will need for graphing the R. Okay, this is for graphing. Okay, so next part will be graphing, but that's okay. You don't need to know that. I mean, later maybe you need, but at this moment just ignore them. And this is what you need. Okay. Now in example number 6. I give you the polar, and I want you to convert to rectangular. So really easy. So we are into rectangular form. Okay, very easy, guys. So R will be what? R will be x squared plus y squared. And 3 sine theta equals 0. So we need to change a little. Sine theta equal what? Sine theta x equal to r cosine, right? So sine will be what? Sine will be opposite, right? Sine will be opposite. Will be hypotenuse. Will be 3. Okay. Will be what? 3 over sine opposite will be y over r, right? We are equal 0, right? Okay. Did we mess up something over here? Oh, I'm sorry. R is I think I'm gonna say R is r squared x squared over. I'm sorry. The relation is this: r squared equal x squared plus y squared. So this x squared plus y squared will be will be square root. Okay, it will be square root, and so we gotta keep going. So we see that x squared plus y squared will be 3y. Will be again will be square root of x squared plus y squared equals 0. So if I go have find LCD, so when we have find, we gotta keep going. So we gotta have LCD will be square root of x squared plus y square, right? Plus 3y over square root of x squared plus y squared equals 0. So from here, we know we multiply both sides by the denominator, so we're gonna have this plus 3y equals 0, and this is x squared plus y squared equal 3y equals 0. There you go, done. Good. See, very easy. Okay, again, a final example will be covering this. Very easy, as long as you know the relationship between the polar and the rectangular, then I'm sure you can do all of this. Okay, again, the graphing part, you can use a graphing calculator, but it's not really important, so I'm going to skip that part, okay? So you don't have to do homework on that part either. It's super easy. I'm going to look at do a pic over here. What does the graphing look like? It's kind of funny because we don't have graphing paper, so how we're just gonna go ahead and draw a bunch of circle and try to do the curve. That's okay, guys. We're gonna stop right over here. All right. If you have any questions regarding to this lecture, please let me know. Okay, and I'll see you next time.